if we start by looking at this surface in white light, this is a black powder finger mark on this surface. Now, the background is actually detracting from the finger mark quite a lot. So in this case, what we're going to use is we're going to try infrared light. So the theory being that what we want to happen is for the black finger mark to absorb the infrared light, and hopefully the background will reflect it. And that will remove the interference that's currently coming from the background. So in order to be able to see the infrared light, I'm going to remove the visible imaging filters from the lens currently attached to the DCS. I will come into live mode so that I can view some different wavelengths of infrared. And then I'm going to use the FLS in this case. So one of the great things about the FLS is that when it's used in conjunction with the DCS, we have access to 600 individual wavelengths of light, and 300 of those are in the infrared. So it allows us to be quite exact when we are searching for contrast, especially in the infrared region of the spectrum. And what we're able to see is how the contrast changes now. Just going to make some slight tweaks to the focus. That looks much better. And so if I move between these two images, we can see the difference that simply changing the wavelength of the light can make. If I put them into grayscale, maybe it will contextualize that even more. So if I move between the two, we can see, especially on this left-hand side, this second print goes from being almost totally obscured by this area of printing to that printing disappearing in the infrared. So those inks are reflecting infrared light, whereas the finger mark that's been powdered over the top is absorbing that light. So again, just by changing the wavelength, we're able to drastically change and alter the results that we can get from our photography.